All of you can give your attendance in the chat box. I repeat, all of you can give your attendance in the chat box. Okay, it is 11:35 a.m. So let us start the class. Let me present my screen first. Give me a minute. Can anyone confirm whether my slides are visible or not?
Yes, sir.
Yes, sir, visible.
Okay, okay, thank you. Just a minute. Okay, fine. So, if you remember in the last class, we solved some problems related to equilibrium equation of forces. Today, we will start a new topic, and this is probably the last topic of this module. And that topic is moment of a force. Now, what do you mean by a moment of a force? So, let me explain this term called moment by an example. Can you see my mobile phone?
Yes, sir.
Yes, sir.
Okay. Let us assume that this mobile phone is a body. Let us assume that this mobile phone is a body, and what I am doing is I am applying a force or a load on this body. Assume that this red color pen is nothing but a force or a load. Body is placed in any direction. It can be placed parallel to your horizontal axis. It can be placed parallel to vertical axis. It can be placed at some angle with respect to any of the axis. Fine. So this is my body, and on this body what I am doing is I am fixing one end of this body. Either I am fixing this end or I am fixing this end. So let us assume that I am fixing this particular end of the body. Now the body cannot move. Body cannot move. So if you apply a transverse force on this body, now what do you mean by a transverse force? Transverse force is that force which you apply perpendicular to the direction of the body. This is the body, and if you apply a force in this direction, now if you see the angle between the force and the body is how much? It is 90-degree angle between this body and this force. So that type of force we call it as a transverse force or a transverse load. Fine. So when you apply a force on this body, can you tell me what will be the tendency of the body? What will happen to this body if you apply a
Rotate, sir.
transverse load like this?
Rotate.
Yes, the body will rotate about this fixed point, about this fixed end. The body will try to rotate about this fixed end. So this moment is nothing but moment is a phenomena which creates a rotation in the body. How? This is your body. This is that transverse force. This force into the perpendicular distance from the point of application. That means that means this body is rotating completely about this fixed point. This body can rotate like this about this fixed point due to application of this transverse load. So if you take the product of which and which thing, product of this transverse force into the perpendicular distance from the point of application of the force, that means this point, till the point where you want to calculate the moment, that means this point, and about this point only my body can rotate completely. That two distance, that product of those two things will give you a moment, and moment produces turning effect or rotational effect on any body. Now is the term clear? What is moment? Any doubt? Please
No,
respond
sir, no,
whether
sir.
any doubt is there or not. Anyone from mechanical department, if you can respond?
No, sir, no,
No,
sir.
sir, no doubt.
Fine. Anyone from electrical department?
No, sir.
Okay.
No, sir.
Clear. So I understood that moment is a physical phenomena which tells us the rotation of a body about a fixed point. So assume that this is a body, this is a rigid body. Fine. On this rigid body a force is applied, this is the direction of the force. Fine. If I need to calculate the moment of this particular force P about this particular point O. This point O is any point in the body. This point O can be over here. This point O can be over here. This point O can be over here. Fine. So I am assuming, say, the point O is over here. If I want to find out the value of moment, how I can find it out? I know that what is moment. Moment I am finding out about a particular point. So can you tell me, by looking at this diagram, at which point I will be calculating the moment? In this diagram, can you tell me at which point I will be calculating the moment? I am interested in knowing the value of moment at point O. So you have to write moment suffix O. That means you are calculating the moment of this body due to this force P at point O. This is the meaning. It is what? It is a product of force and perpendicular distance. Which force? The force which is applied on the body, and in this body the force applied is P. So P into perpendicular distance from where to where? From the point of application of the force till that particular point from where you need to find out the value of moment. So if you see in this direction, this is the direction of the force, this is the line of the action of force. I need to find out the value of moment at point O. So this will be the perpendicular distance. If you see, the angle between this force and this distance L is how much? 90 degree. Angle between this force P and this distance L from point O is how much? 90 degree. So the moment will be P into this distance L. Is it clear? Any doubt?
Yes, sir.
Okay. So now can you tell me whether moment is a scalar quantity or a vector quantity?
Sir, vector, I think.
Moment is vector
Moment is
quantity.
a vector quantity. How you can say that moment is a vector quantity?
Sir, it have a particular direction of rotation.
Okay. What else? Vector quantity has magnitude as well as direction. Since moment can make a body rotate. That means direction is involved, as well as there is some particular value of the moment. For example, 400 Newton meter, 400 Newton centimeter. That means it is having the magnitude as well as it is having the direction. So moment is a vector quantity. Now can you tell me what is the unit of the moment? Can anyone tell me what will be the unit of the moment? Mathematically, moment is expressed as force into perpendicular distance, and that distance will be calculated from the point of application of the force to that particular point where you need to calculate the moment. So this is mathematically you can denote moment as F into D. F is the force applied and your D is the perpendicular distance. D is the perpendicular distance from point O, because in this body I am interested in rotating this body about point O. So the moment will be force F into perpendicular distance from the point of application of the force to this fixed point O, F into D. So now can you anyone tell me what is the unit of the moment?
Sir, Newton meter.
Yes,
Newton meter.
it can
Newton
be
meter.
Newton meter, it can be Newton millimeter if the distance is in millimeter, it can be Newton centimeter if the distance is in centimeter, it can be in CGS unit, it can be in MKS unit. So basically you can say that unit of moment is Newton meter, Newton millimeter, Newton centimeter, kgf millimeter, kgf centimeter if Newton is expressed in terms of kilogram force likewise. Fine. Now there is a sign convention which you have to take while solving problems related to movement. What is that sign convention? Fine. Say I am having this mobile. I am fixing this mobile at the leftmost end and I am applying a transverse force on the other end of the mobile like this. So can you tell me the direction of rotation, whether it is clockwise or
Clockwise movement.
anti-clockwise? Hello?
Sir, clockwise movement.
Yes, if you see, if I apply the force like this body has a tendency to rotate in clockwise direction. So there can be a clockwise moment in a body as well as there can be an anti-clockwise moment in a body. How? The same body, if I fix at the left end, if I make this body free at the other end, and if I apply a transverse force in this direction, in the positive y-axis, now what is the direction of movement, clockwise or anti-clockwise? What is the
Anti-clockwise.
direction of movement? It is
Anti-clockwise.
anti-clockwise. So now the sign convention is, see, it is very much clear from the diagram. Fine. I am having a bar whose length is D. If I am taking a transverse force along positive x-axis at this particular end, it will be an anti-clockwise movement at point O. Similarly, the same bar, if you take a transverse force along negative y direction, then it will be a clockwise movement at point O. So now the sign convention is, if you are solving a problem, if in a problem multiple times clockwise moment is acting and multiple times anti-clockwise moment is acting, then what to do? Then if you are taking clockwise moment throughout the problem positive, you have to take it positive, and if you are taking anti-clockwise moment throughout the problem negative, take it negative. Choice is up to you. If you are taking clockwise moment positive, you have to take anti-clockwise moment negative. If you are taking anti-clockwise moment positive, you have to take clockwise moment negative. But you cannot change. Say if in a single problem, 3 times clockwise moment is acting and 4 times anti-clockwise moment is acting. So first time you are taking clockwise positive, second time you are taking clockwise negative. You cannot do like that. You have to solve the entire problem either by taking anti-clockwise positive or by taking clockwise positive and vice versa. Is the sign convention clear? Any doubt so far?
No, sir.
Okay. It will be more clear to you once we solve the problems. Okay, so let me move to the next slide. Next slide is about the theorem of Varigon. It is an important theorem. It can be asked in the examination for 7 marks. And this theorem is applicable to solve several problems related to moment. What is the theorem of Varigon? According to this theorem, the moment of a force about an axis is equal to the sum of the moment of its component about the same axis. That means, if I want to understand, assume that this is a body. On this body, say this force acting at the end is F1, another force acting at the second end point of the body in positive y direction is F2, and resultant of F1 and F2 is, say, this R. Say this R, this is the resultant of F1 and F2. Then, according to this theorem, find moment produced by the resultant will be equal to the summation of moment produced by this force F1 as well as moment produced by this force F2 at any particular point in the body. That point will vary from problem to problem. Is the definition clear? Is the statement clear of this theorem? Any doubt? Hello?
Sir, please repeat once.
Hello?
Sir, please repeat once.
Repeat once. Okay. What is the theorem of Varigon? Okay, let me erase all these things. Theorem of Varigon states that the moment of a force about an axis is equal to the sum of the moment of its component about the same axis. For example, if I assume a body, this is a body, and for this body, this is your y axis, and this is your x axis. That means this body is kept in xy plane. On this body, assume that F1 force is acting along positive x direction at one end point of the body. F2 force is acting along the second end point of the body along positive y direction. Resultant of F1 and F2 is, say, F. F is nothing but the resultant of force F1 and F2. Then according to this theorem, moment of this force at any point in the body, that will be equal to summation of moment of the component of this force. In this diagram, it is very much clear that this resultant force is having two components. One is F1, another one is F2. So moment of this particular force will be equal to summation of the moment of its component. That means summation of moment due to force F1 plus the moment which is acting due to this force F2 at any particular point in the body. This is the statement of this theorem. Is the statement clear?
Yes.
That means say I am interested in calculating the moment at this particular point. Say this distance which the resultant is making from this point to this point is d, and the distance which the component of the resultant f, that is f1, it is making, say, d1, till this point, and for F2 say this distance is d2. Then according to this theorem, moment is what? Moment is force into perpendicular distance. Here I am interested in finding out the moment at this particular point. So for resultant force, moment will be F into d, because this is the perpendicular distance. So according to this theorem, F into d will be equal to summation of moment of this, but of summation of the component of this resultant force. One component is F1, another component is F2. So moment of F1 will be F1 into D1 at this particular point. So F1 D1 plus moment of this particular force F2 at this particular point is F2 into this distance is D2. F2 into D2. This is the statement of the problem. Now it is clear. Any doubt?
Yes, sir.
Okay. Anyone from the mechanical department, if you can confirm?
Yes, sir.
Okay, fine. So now we have to prove this
Just
statement.
repeat this part.
Again, I am repeating. Okay, I have told it 2 times. Okay, one more time I am saying. Please listen it carefully. It is. According to this statement, if in a body more than one force is acting, assume that this is a body. On this body, at one end of this body, force F1 is acting. At the other end of the body, force F2 is acting. Now there will be some resultant force, resultant of F1 and F2. There will be some resultant. Assume that resultant is F, and that is acting at this particular point of the body. This is F. Say the end point of the two bodies is AB, and the resultant of F1 and F2 is acting at point C. Fine. According to this statement, if I am interested in finding out the moment of the entire body at this particular point, say this particular point is having a distance d1 from the force F1, it is having a distance, perpendicular distance d2 from the point of application of force F2, and it is having the perpendicular distance say d from the resultant force F. Then according to this theorem, moment of this resultant force about this point, say this point is D, moment will be how much? F into D, because formula of moment is force into perpendicular distance from the point of application till that point where you are calculating, and here the angle is 90 degrees. So F into D, this is the moment of the resultant force, that will be equal to the summation of the moment at same particular point by the component of those forces. F is having two components, one component is F1, another component is F2. So for F1, moment will be F1 into D1 at this particular point, F1 into D1 plus for force F2 at this particular point, moment will be F2 into D2. F2 into D2. This is the statement of Varigon's theorem. Is it clear now? Is it clear?
Yes, sir. Yes.
Okay. Now in problem there can be multiple force. Here I have shown you two force. Resultant of F1 and F2 is F. In a problem there can be 10 force. There can be 15 force. There can be 5 force. But theorem. What is the theorem? Theorem is the moment of the resultant force will be equal to the summation of the moment of all the component of that resultant force. That is the statement. Fine. So now we are interested in proving this statement. We have to prove whether this statement is true or false. For that, what we are doing is, let me erase all these things first. I am taking a 2D plane. This is my x-axis. This is my y-axis. Assume that point A is the origin point. From point a force is acting. That force is this force F, making an angle theta. This particular angle is theta, and this is that force F. This is that force F. It is making an angle theta with respect to x-axis. Clear? Let this force F is having two components. One force is force F1, which is making an angle theta 1 with respect to x-axis. Another force is F2, which is making an angle theta 2 with respect to x-axis. That means this is my F1, this is F1, and this is F2. I can very easily find out the resultant of this force by parallelogram law. That means from F1, I have to draw a parallel line of length F2 parallel to this F2. Similarly, from this F2, I have to draw a line parallel to this force F1 and of same magnitude. This is a parallelogram. Then the resultant will be the extreme diagonal point. If you join the extreme two diagonal points, this is the resultant. This is your force F. This is that force F. And this force F is making an angle theta with respect to x-axis. Force F1 is making an angle theta 1 with respect to x-axis, and force F2 is making an angle theta 2 with respect to x-axis. Till this much the diagram is clear?
Yes, sir.
Okay. Now let us assume that this force, resultant force F, this resultant force F will have two components. One component along x-axis, another component along y-axis. If we can prove this statement for one particular component, for another component it will be proved as it is. If you do the analysis part for the y component, fine. If we can prove that this statement is true for x component of forces, the same theorem will be true if you consider the y component of forces. So let us solve for one component of force, and if the statement is true, then for other component of forces also it will be true. So let us assume that this force F is having a component along x-axis, and that component is Fx. That means from this force, drop a vertical line. From this origin, drop a vertical line. This will be the magnitude of Fx. Similarly, F1, which is the F1 and F2 are the component of this resultant force. Similarly, F1 and F2 will have their x component. So from F1, drop a vertical line. From origin, drop a vertical line. This will be your Fx1, horizontal component of force F1. Similarly, for F2, drop a vertical line from F2. From origin, drop a vertical line. This will be the horizontal component of force F2, that is Fx2. Is it clear so far? Fx1, Fx2 and Fx. Any doubt?
No, sir, no doubt.
Okay. Let me erase all these things first. Fine. Now, in order to prove this statement, since this statement tells us about the moment, so I need to take the moment of these three forces. Forces F1, force F1, force F2, and force F. Let us take a moment. For that, what I am doing is, on this y-axis, I am taking a point called O. So I am interested in finding out the moment of force F about point O, of force F1 about this point O, and of force F2 about this point O. For that, what I need to do, I need to get the perpendicular distances, because then only I can apply the equation of moment, that is force into perpendicular distance. So for each of the forces, I have to get the perpendicular distance from point O. Is it clear?
Yes, sir.
Okay, so how I can get? So this is your force F. Fine. This is your point O. So from point O, drop a perpendicular. From point O, drop a perpendicular on this force F. Now this distance will be that perpendicular distance, and that is denoted by small d. Now if you take the moment of this force F about point O, moment will be MO, will be how much? It will be force F into this perpendicular distance d. Is it clear? Any doubt?
No, sir.
Okay, okay. Similarly, I have to get the perpendicular distances for force F1 and for force F2. So for force F1, this is the force. This is the force F1. This is your point O. From point O, say this is your perpendicular distance. This is your perpendicular distance. Let this distance be nothing but d1. For force F1, distance is d1. Is it clear?
Yes, sir.
Okay. Similarly, for force F2, this is your force F2. I am interested in calculating the moment of this force F2 at point O. So from point O on this force F2, I have to drop a perpendicular, and this particular distance will be how much? It will be, say,
D2.
D2. Is it clear? Any doubt?
No, sir.
Okay. So likewise, if you see in x-axis, force F is making an angle theta with respect to x-axis, F1 is making an angle theta with respect to x-axis, F2 is making an angle theta too with respect to y-axis. Similarly, these perpendicular distances will also make an angle. Assume that this perpendicular distance d, which you are taking from force F, is making an angle theta. Similarly, for force F1, this is the perpendicular distance. Angle made from the y-axis is theta 1. Similarly, for force F2, this is the perpendicular distance, and angle made from the y-axis, that means this much angle is theta 2. Is it clear? Is it clear? Any doubt?
No, sir. No doubt.
Okay, so our diagram is completed. So this is the explanation of this diagram. Now we have to prove this theorem. For that, what I am doing is, first of all, I am calculating what? I am calculating the moment of force F about O. I am calculating the moment of this force F about point O. Can you tell me what will be the value of moment by looking at this diagram? Moment of force F about O.
F into D.
F
F
into D.
into small d. F into small d. Very good. So it is F into D. Again, I can write D. I can write D in some way. How? In what way I can write? If you consider triangle, that means, so let us assume that this perpendicular distance is bisecting your force F at point M. At point M. So if you consider this triangle, which triangle? Triangle O, triangle, sorry, the side O, wait, O, A, M. This is a triangle. If you consider this triangle, this angle is theta. This particular angle is theta. Fine. Then you can write that cos theta is equal to base by hypotenuse. So you can write cos theta is equal to base. Base will be what? Base is this D itself. This D is your base. So D divided by hypotenuse. Hypotenuse is the longest side, and this longest side is this OA by OA. So you can write D is equal to OA cos theta. So in place of D, you can write OA cos theta. Is it clear?
Yes, sir.
Yes, sir.
Okay. So FD is equal to F into OA cos theta. Take OA out of the bracket and take F inside the bracket. Your equation becomes F into D is equal to OA into F cos theta. So if this is F cos theta, so can you tell me from the diagram that you can replace F cos theta by which term? Can you tell me from the diagram you can replace F cos theta by which term? From the diagram, you have to replace F cos theta by a term. That is which term?
Fx.
Fx. If you see, this is my force F, and this is the angle theta. It is having two components. One component is this Fx, that is this Fx, which will be F cos theta. So in place of F cos theta, I am writing it as Fx. So my final equation becomes F into D is equal to OA Fx. Equation number 1. Any doubt in equation number 1?
No, sir.
No, sir.
Similarly, I have to find out the moment of force F1 about O as well as the moment of force F2 about O. Let us find it out. Let us find it out. So now you have to tell me. You have to tell me the answer. Fine. I have told you for this force F. So moment of force F1 about O. Moment of force F1 about O will be what? From the diagram, tell me. In terms of F and D.
F1.
F1 D1.
F1, this is my force. This is my force F1. And I am interested in calculating the moment at this point. Oh, so I have to find the perpendicular distance passing through force F1, that is this distance D1. So it will be F1 into D1. Again, you have to write D1 in terms of OA and cos theta. So if you consider triangle, this triangle, that is O, A, N, this triangle if you consider, and this is your theta 1, this is your theta 1, then you can write cos theta 1 is equal to base. Base is your D1 divided by hypotenuse, that is the longest side of the triangle, which is OA. So you can replace D1 by OA cos theta 1. So D1 I have replaced by OA cos theta 1. Again take OA outside the bracket, F1 inside the bracket, OA into F1 cos theta 1. Now this F1 cos theta 1 can be replaced by which term? F1 cos theta 1 can be replaced by which term?
FX1.
Fx1, yes, because F1, this is F1, it is making an angle theta 1 with respect to x-axis. It will have two components. I am interested in x component. This is my x component Fx1, which will be F1 cos theta 1. So in place of F1 cos theta 1, you can write Fx1. So the final equation becomes F1 D1 is equal to OA Fx1, equation number 2. Any doubt in equation number 2?
No, sir, no doubt.
Okay, fine. So likewise, we can also calculate the moment of the force F2 about O. So can you tell me from the diagram what will be the moment of force F2 about point O in terms of F and D? F2 D2. Yes, it will be. This is my force F2. I am interested in getting the moment at point O. So this is that perpendicular distance passing through force F2. F2 into D2. So F2 D2. Again, you have to replace D2 in terms of OA and cos theta. For that, can you tell me which triangle I will consider? O side OAP. This triangle OAP. This angle is theta 2. So cos theta 2 is equal to base. Base is D2 upon hypotenuse. Hypotenuse is OA. So D2 becomes OA cos theta 2. D2 becomes OA cos theta 2. Fine. OA take out of the bracket, F2 take inside the bracket, it will be F2 cos theta 2. Now from the diagram, can you tell me what is the value of F2 cos theta 2? Fx2, very good. It is Fx2. So I can replace F2 cos theta 2 by Fx2, equation number 3. So what is the statement? Statement is resultant moment of the resultant force F will be equal to the summation of the moment of individual component. So this is the moment of individual component force F1, that is equation number 2, and for the force F2, your equation number 3 is the moment. So if we add equation 2 and 3, that is only what we have to do. That is there in the statement. So add equation 2 and 3, that is F1 D1 plus F2 D2 is equal to OA Fx1 plus OA Fx2. You can take OA common, equation becomes F1 D1 plus F2 D2 equal to OA in bracket Fx1 plus Fx2. And we know that Fx1 plus Fx2 is always equal to the resultant force F, which is Fx. That is the law. That is the law in mechanics, that resultant force F will be always equal to the summation of the resultant of individual component. That means Fx will be equal to Fx1 plus Fx2. So Fx1 plus Fx2, I can write it as Fx. Now, if you see the right hand side equation, it is what? It is OA Fx. And if you see equation number 1, OAFX, I can write it by the term called FD. So replace this OAFX by FD. Your equation will become F1D1 plus F2D2. F1D1 plus F2D2, which is equal to OAFX is FD, which is the statement of Varigon's theorem. That is, moment of the resultant force is equal to the summation of the moment of its individual component. Hence proved. And this Varigon's theorem will be applicable if you analyze the entire system along y-axis. If you do that, in that case, you have to take this point O from the x-axis and you have to solve the problem. Is it clear? Any doubt? Any doubt in this Varigon's theorem? Okay. Anyone from the mechanical department, if you can
No,
respond?
sir, no doubt.
Okay, fine. Next is the equations of equilibrium. Next is equations of equilibrium. So far what we have studied, so far we were not knowing about moment, that moment also act on the body. So far what we know that if I am having a body, if I need to keep this body in equilibrium, summation of all the forces along all the axes should be equal to 0. That means summation fx equal to 0, summation fy equal to 0, and summation fz equal to 0. If there is a 3D body and if I want to keep that body in equilibrium, fine. But now since moment is also acting on a body with force, now that equations of equilibrium will change. Now for a body to be in equilibrium, you have to check that all the forces, summation of all the forces along all the axes should be equal to 0, as well as summation of all the moments along all the axes should be equal to 0. If a moment is acting in the body, if moment is not acting in the body, or if the body is not rotating in nature, then no need to check. Then only you will check fx0, fy0, fz0. But if the body has a tendency to rotate due to any kind of force, that means moment is acting on the body, then in that case equations of equilibrium changes, and that will be fx equal to 0, summation of fy equal to 0, summation of fz equal to 0, and summation of mx, that is moment about x-axis, equal to 0, summation of my equal to 0, and summation of mz equal to 0. Is it clear? Now this is the modified form of the equations of equilibrium. Any doubt? Hello?
No, sir, no doubt.
Fine. Okay. I will take 10 more minutes of you. We will solve one problem and then you can leave. You can leave by 12:30. I will take 10 more minutes. One simple problem is there. It will clear all your doubts. How to take the moment, what is clockwise moment and what is anti-clockwise moment. So let us solve a small problem, simple problem. The problem is two beams, AB and CD. This is a beam. Now first let us understand what is a beam. Can you tell me, can anyone knows what is a beam?
Yes, sir, yes, sir.
What is a beam? Can you explain?
सर मतलब एक पूरा सिस्टम रहता है बेसिकली यूज फॉर लिफ्टिंग पर्पसेस मतलब एक टाई रॉड के साथ अटैच रहता है बीम और
See,
उसका
beam is basically a horizontal member.
ये सर हाँ horizontal
तुम आपको उसका बता रहे हो कि उसका
हाँ।
हाथ कैसा होगा, उसका पैर कैसा होगा, वैसे बोल रहे हो. आपको मेन आंसर चाहिए. बीम इज व्हाट? बीम इज अ हॉरिजॉन्टल मेंबर. जब आपका घर बनता है, घर के जब आपका छत का जब छत का ढलाई होता है, तो वहां पे देखना, वहां पे बहुत सारे हॉरिजॉन्टल रॉड्स लगाते हैं. तो क्या है वो? एक बीम ही तो है.
हाँ सर
तो एक बीम ही तो है. ठीक है. सो बीम इज व्हाट? बीम इज अ हॉरिजॉन्टल मेंबर. फॉर एग्जांपल दिस इज अ बीम ऑन व्हिच different type of load acts. Different type of load act and this beam is supported at both the ends. तभी तो ये बीम न्यूट्रल पोजीशन पे रहेगा. अगर आप दोनों एंड पे सपोर्ट नहीं दोगे तो ये बीम गिर जाएगा. Fine. So that is a beam. So two beam AB and CD are arranged. AB is one beam and CD is another beam. They are arranged and supported as shown in the figure. See, this beam AB is supported at point A and the beam CD is supported at point D as well as at point C. And both the beam is having a common support at point E. Find the reaction at D. You need to find the reaction at D. That means this support will exert a reaction at the end point of the beam D. That you need to find out due to force of 1000 Newton. This is a 1000 Newton force acting at point B at an angle of 30 degree. And the entire length of the beam is 4 meter. That means distance between A and C is 1 meter. Between C and E distance is 1 meter. Between E and B distance is 1 meter, and between B and D distance is 1 meter. Is the question clear? Any doubt? Any doubt in the question?
No, sir, no.
Okay, so what I need to find out? I need to find out the reaction exerted by this roller at point D. So before that, first you have to analyze. So can you tell me whether in this problem rotation is happening or not? If rotation is happening, then moment will come. If the rotation is not happening, moment will not come. So first you have to identify, you have to analyze the problem and tell me whether the rotation is coming or not. Tell me.
Yes, sir. Rotation will come.
Rotation will
Yes, sir.
definitely come. It is very much clear from the diagram. Fine. See, that means this beam is having a tendency to bend, to rotate. That means moment will act. So for that, the very first step is what? Very first step is drawing the free body diagram. So let us draw the free body diagram of both the beams, beam AB and beam CD separately. If I draw the free body diagram of beam AB, so you can say that this 1000 Newton load, it is acting at 30-degree angle at point B. So it will have two components. One component will be along y-axis in this direction. Another component will be along x-axis in this direction. Can you tell me what will be the value of this y component? What will be the value of this y component? This is 1000.
1000 sin 30.
Yes, since this angle is given, since this particular angle is given 30-degree, so this is the tail end, this is the head end. From the tail, I have to go vertical. From this point, I have to go horizontal. So this is how I will resolve. This value will be 1000 sin 30, and this particular value will be 1000 cos 30. Fine. And you see this beam is supported by a roller at point E. So roller will give a support in positive y-axis like this, RE, to this beam AB. Yes or no? Hello.
Can
Yes,
please
sir.
repeat?
Fine.
Sir,
So
please repeat.
this we have drawn the free body diagram of this 1000 Newton load. One is 1000 sin 30 and another one is 1000 cos 30. Now if you see, both the beams are connected by a common roller. So this roller will give a reaction to this beam AB in positive y direction, that is RE. Clear?
Yes, sir.
Fine. So one last reaction is left, that is RA. Can you tell me the direction of RA? What will be the direction of RA? Whether it will be horizontal or it will be vertical or it will be inclined at some angle. That means the roller will give the reaction to the end point of the beam A. Can you tell me
Sir,
what will be the reaction?
horizontal.
Horizontal.
Sir, horizontal.
Horizontal. Why horizontal? It will not be horizontal. Can you please mute your mic? Okay. It will be in this direction. See why it will be in this direction, RA. I have told you that while drawing the free body diagram, you have to keep in mind that you have to find out the equilibrium point. And equilibrium point is that point from where either all the forces originate or all the forces terminate, or some of the force originate and some of the force terminate. Now see, line of action of RA is this. Line of action of this 1000 Newton is this. So definitely I have to draw, or the reaction RA will be in this inclined direction. Then only see, all the forces will meet at a common point. Understood?
Yes, sir.
So it will not be horizontal, because see, this R, this 1000 sine 30 and 1000 cos 30 is not given in the problem. We are drawing it in the problem, but actually the force is 1000 Newton, which is making an angle 30° with respect to horizontal. So direction of RA will be this. That means this left hand side diagram. Is it clear? The FBD of B maybe? Any doubts? Any doubt? Okay, I hope there is no doubt. So I need to calculate the unknown values in this AB, in this beam AB. If you take, since the entire problem can rotate, so if you take moment at point A, if you take moment at point A, that means this is your beam, this is A, this is B, this point is fixed. Taking moment at point A means this point is fixed. Now this beam AB can rotate like this, can rotate like this. So if you take moment at point A and if you equate it equal to 0 for keeping the body in equilibrium, what you can do? Then see, one force is RE. RE into which distance I have to take? I have to take this distance 2, because I am interested in calculating the moment at point A, and I know the definition of moment as force into perpendicular distance. So this is your force. This is your force RE into perpendicular distance. From which point to which point? From the point of application of force to that particular point where you want to calculate the moment. I want to calculate the moment at point A. So distance will be RE into 2. But it is positive or negative. For that, I have to decide whether the moment is clockwise or anti-clockwise. Decide. RE into 2. This moment is clockwise or anti-clockwise? Hello? This RE into 2 is clockwise or anti-clockwise?
Clockwise.
Clockwise.
How come it is clockwise?
No, sir, anti-clockwise.
Sir, anti-clockwise, sir, anti-clockwise.
And this is point 3. So the body is rotating like this. So it is a, can you please notice? So it is like a body is rotating like this. That means it is going in anti-clockwise direction. So here they have taken anti-clockwise moment negative. So if I am taking anti-clockwise moment negative, throughout the problem I will take it negative, and throughout the problem I will take clockwise moment positive. So sorry, they have taken it positive. They have taken it positive. So RE into 2. RE into 2. This is moment, as well as this 1000 Newton is having two component. This 1000 Newton is having two component. One component is horizontal component. This one 1000 cos 30, and another component is horizontal component 1000 cos 60. So can you tell me that whether we will be taking both the components 1000 cos 60 and 1000 sine 30 for calculating the moment, or we will take only one component? My question is whether we will take 1000 cos 30 into the entire distance 3 meter, or we will take 1000 sine 30.
Sir, only one component will be required.
Which component I will take?
Sir,
Cos
sine one,
30. Cos
No, sir,
component or sine component?
sir, sine वाला.
साइन वाला क्यों नहीं लूंगा कॉस वाला? इसका रीजन क्या है?
सर साइन वाले से हम लोग का मोमेंट लग रहा है ना, मतलब वो डाउनवर्ड जा रहा है.
If you see this cos component of force, this force is passing through that point from where you are interested in calculating the moment, and it is not trying to rotate your body. So I will not take that force. Only I will take this vertical component of force, because this 1000 sine 30 into 3 meter will make your body to rotate. So that's why, and it is a clockwise moment. So minus 1000 sine 30 into the perpendicular distance, that is 3 meter, which is equal to 0. And neither I will take this force RA also. Again, it is passing through point A, which is not trying to make this body rotate. Is this concept clear? क्या ये concept clear हुआ सभी को? जिस पर्टिकुलर पॉइंट पे आपको मोमेंट लेना है, उस पर्टिकुलर पॉइंट से अगर कोई भी फोर्स पास हो रहा है और अगर उसका डायरेक्शन परपेंडिकुलर नहीं है, you will not take that force into account in order to calculate the moment. Is it clear?
Yes.
Fine. Okay.
Yes, sir.
So it will be RA into 2, which is anti-clockwise moment. I have taken it positive, and this 1000 sine 30 into 3 is a clockwise moment. So negative, minus 1000 into 3 sine 30 equal to 0. With this equation, you get the value of RE, that is 750 Newton. Once you get the value of RE, now next what you do, you draw the free body diagram of this beam CD. What will be the free body diagram? So now this time this roller will give a support to this beam CD in downward direction through point E like this. This will be the direction RE. This at D point, due to this roller, reaction will be in this direction, RD, and from point C, the reaction which the roller will give to this beam at end C will be in this direction again. Then only all the force will meet at a common point. See, this is the line of action, and this is the line of action of RD. All the forces is meeting at a common point. So this will be the FBD of beam CD. See, RC, RE, RD. Is it clear? FBD of beam CD?
हाँ sir.
Fine. Okay. So now if I just extend this line, this is a triangle. I know that this angle is 90 degree. This is 60 degree. So this angle will be how much? This angle will be how much?
30 degree.
If this is 30 degree, then from point D, if this is my x-axis and this is my y-axis, this is your force RD. If you extend, then this angle is also 30 degree. See, this angle is also 30 degree. Is it clear?
हाँ sir.
So this RD will have again two components. This RD will have again two components. One is this perpendicular component, which will be RD sine 30, and another one will be horizontal component, that is RD cos 30. Why I have taken direction in this way? Because this is your RD, this is the tail end, this is the head end, and this angle theta is given. I need to go from tail to this head. So I will go in this direction, and then from this end I will drop a perpendicular like this. This is 30 degree. So this will be RD cos 30, this will be RD sine 30. Now you tell me at which point I will take the moment. So let us take the moment at point C, because I need to get the value of RD. If you want to get the value of RD, because that is what required in the question, you cannot take moment at point D, because if you take moment at point D, from point D your force RD is passing, you will not get that force, so you will not take the moment about point D. Either you have to take the moment at point C, from point C, or you need to take the moment from point E. If you take the moment from point E, your RC and RD, two unknown will be there. again it will be difficult to solve the problem. So if you take moment at point C, RE is already known to you from the FBD of beam AB. One unknown will be there, that is RD, and easily we can calculate the value of RD. So that's why I have taken moment at point C. I haven't taken moment at E, neither I have taken moment at D. Is the step clear?
Yes.
Fine. Okay. So if I take moment at point D, can you tell me which component of RD will I take? Will I take the cos component or will I take the sine component?
The sign.
Only sine component. And so RD sine 30 into perpendicular distance. Can you tell me from the diagram what will be the perpendicular distance? Moment about
3.
point C. Distance will be
3.
3 meter, that is RD sine 30 into 3. Positive moment or negative moment, that means either it is clockwise or it is anti-clockwise. Which moment it is?
Anti-clock.
Anti-clockwise moment. So it is positive 3 into RD sine 30. Then I will not take this value RC because it is passing through point C, so it will not rotate the body. Then I will take this force RE. RE into which distance? RE into
Sir, 1 meter.
RE into 1. Now the
1.
sense of the moment, positive moment or negative moment. So for that you have to see whether it is clockwise moment or it is anti-clockwise moment. Can you tell me which moment it is? RE into 1 at point
Clockwise
C.
movement. Clockwise
It is
movement.
clockwise moment. In the entire problem I have assumed clockwise negative, so minus RE into 1. RE is 750 minus 750 into 1, so RD comes out to be 750 divided by 3 sine 30, so RD is 500 Newton, and this is what you have to find it out in this problem. Clear? Any doubt? Okay. With this, I hope you might have understood the concept of moment. Today, I have made you solve very simple problem to get the idea what is a moment, how a moment acts on a body, and which moment we have to take, which moment not to take. In the next class, we will solve some typical problems. Till then, I am ending the meeting over here. If you have not given the attendance, please give your attendance. And if you have given, you can leave the meeting. Thank you.
Thank you, sir.
If anybody is left to give the attendance, they can give it, or else you can leave the meeting.